Hey, hi guys. Like she said, my name is Remy Evans. I'm this year's PPI circuit writer. To kind of summarize what my position is, I work with a multitude of companies throughout the state of Kansas on smaller individual projects. So all the other interns, for the most part, were stationed with a specific company, whereas I was a little more dynamic and was traveling out of Manhattan to go visit these locations. So to kind of show you where I've been this summer, I visited 6 different facilities. I'm based out of Manhattan, so we did have one here, and then you can see kind of sprinkled around Clay Center, Ottawa, Wichita. Fun fact, this was my first time ever in Wichita, was actually on this visit. And then I went as far west as Ellsworth. So that's kind of a good summary of where I've gone this whole summer. And for the projects, I did find 7 unique projects evaluated, and that's going to be different companies all had the same project. So overall, I think I had around 15 individual projects, but categorizing them in these right here, I had about 7. So the biggest one that I could see from all of these different facilities was lighting conversion. We did a lot of replacing with LEDs. Compressed air audits. We had a few solar panel projects, which was definitely a very new concept to me, but we'll go into that a little bit later. Water recycling, there was a boiler replacement, solvent recycling, and finally electric forklifts. So we had a very wide range of projects to work on this summer. It kept me very entertained. So starting off, we have the lighting conversion. I visited 3 different facilities that requested a lighting audit. A lot of these were out on the shop floor. I did, however, evaluate one office space on top of the shop floor. Most of these facilities have fluorescents with magnetic or electronic ballasts, and we were looking at converting them to LED. There was a couple facilities that had very high energy fixtures with 6 lamps, 2 ballasts, very high energy costs, and there's a few with metal halides and high pressure sodiums as well, which are pretty high wattage as well. So what we ended up recommending is to replace with LEDs and do a ballast bypass. How we got to this recommendation is we would show up to the facility, tour the facility. Like Abby mentioned, we counted a lot of light bulbs and fixtures. We used the light meter to record lumens and foot candles so we can kind of evaluate what kind of lighting we need in these facilities for the workers' safety and comfort of your eyeball, I guess. We also used a ballast discriminator just to help us kind of differentiate between that magnetic versus electronic ballast. The electronic ballast is going to be a little bit more friendly for our purpose than magnetic. So after considering all of these things, we were able to pull down a lot of bulbs and tubes from our point of contact and get wattages on them, where we then used a lighting workbook. We plugged in the hours, the cost of electricity, the amount of bulbs, fixtures, and so forth. And that kind of spits out our numbers that you are going to see here. So overall, out of these 3 facilities, I was able to get around 374,000 kilowatt hours reduced, which putting that into our EPA GHG calculator, we get around 363 metric tons of CO2 equivalent reduced. Overall, this is going to save these 3 companies around $31,000. Moving on, we had our compressed air audit as well. This was 3 facilities too. Overall, we identified 110 leaks, which is quite a large number, and that's something that was very shocking to me. I did not realize that air compressor leaks were that large of a problem. So how we identified these leaks is we show up to the facility. We asked if we could use the UE 9000 ultrasonic probe. And so essentially what this does is it identifies the leaks. We wear a giant set of headphones. It kind of looks like a laser tag gun, sort of. And we walk around and we wave it and we listen on the headphones for the really quiet leaks, which then are going to read back a decibel rating, which you might not be able to see, but it's on like this little tiny screen on the top left. We read that decibel rating, and then using the UE app, it's called Sidekick Survey, Leak Survey, excuse me. We plug that decibel rating in along with cost of electricity, hours of operation, and that same thing as the light book kind of spits out a number to us. And that's how we generate our costs. So overall, most of these leaks were found on the pneumatic tooling, hose connectors. I should have included a few pictures, but there are 110 leaks. It's hard to pick some of the best ones. But lots of connectors. There's going to be a leak somewhere around there. There was a couple situations where there was just a cut in the hose. So that's where we found most of our leaks. To summarize my findings, we're going to save about $48,000 between these three facilities if they end up fixing all these leaks. Over 491 thousand kilowatt hour impact, and we're going to reduce about 476 metric tons of CO2. Okay, for solar panels, this one was a very tricky project for, I think, all of PPI. I know there's quite a few interns as well that had to work on a solar panel project. So this was simply something new, as I'm not a solar panel specialist. Therefore, my first step was kind of consulting with a few specialists that do know what they're talking about in solar panels and trying to get a good estimate of how I should approach this project without going too deep into all the rabbit holes. So the first thing that I did when we showed up to these facilities that were requesting solar panels is ask what their goal was with solar energy. There's a lot of different goals. A couple of them include reliable energy. They want, more connectivity than what their grid can offer. Another one is just to cut back on electric costs, energy savings. That's quite a few examples. So once we understood what their company goal was, whether that be net zero or just more reliable energy, we went ahead and kind of asked them where they would ideally like these solar panels placed. Most of them said the roof. There was one or two that said around the facility due to roof complexions. But moving on from once we understood that, what we ended up doing was using the PV watts calculator, which is a National Renewable Energy Laboratory resource. And what we would do with that is we would find the location of the facility, estimate how many kilowatts their system could produce with solar panels, and we would end up generating with all of the example inputs, we would end up generating a AC energy savings per month. So therefore, from that output that we see from PV watts, that's going to be what our potential solar system can produce. So we're going to take a look at the energy bills that we were provided by the company, and we're going to subtract the new savings that PV watts outputs from the previous monthly bills. And then that from there is going to give us our savings that we can see by implementing a solar panel installation unit. Let me think. So I have written down the net metering system. Kansas is a net metering limit of 200 kilowatts, which is actually not terribly large now that I'm looking at a couple of my facilities. So what net metering is it's basically connecting you to the electrical grid. And when you are generating solar energy, there's going to be a cap where you are not producing any more. You're producing more energy than you're using. So with net metering, you're able to send that back into the grid kind of as a cheap energy, and you're going to get credits from that. So that's kind of where we were. A lot of companies would like to stay within that net metering range because, especially if they're not a 24/7 operation, if you're not a 24/7 operation, when the sun is shining, you're working during that day. But then everyone goes home at night, but you're still going to have all this energy that's built up, especially if you're done at 2:30. Then from 2:30 to 8, you're still having that solar output, but you're not using it. So having that net metering system where you can send it back instead of just ended up wasted energy is definitely ideal. And then there's a couple grants to also consider, which is the REAP grant and the ITC, which is a federal tax credit for solar investments. So lots of rabbit holes, but we finally got to a couple steady numbers, which are going to be, around 1,100 metric tons of CO2, over 1 million kilowatt hours reduced, and about $74,000 savings between the three facilities that I estimated the feasibility. That was definitely the trickiest project. So moving on, water recycling. This one was also kind of different. We only did water recycling for one facility, which they have a spinner station, which they would like to, the spinner station, excuse me, let me go back. This spinner station goes through 3 different cycles where they use 3 gallons per minute, 2.5 minutes per cycle. And that's how they're going to clean out a tote is essentially what they're going to do. So what they would like to do is they would like to recycle that third and second cycle of water from the spinner station and just loop that for the rest of the day. And that's kind of where they would expect to see some savings. So there's a few complications with this, being that how dirty can your water be for it to be able to be reused before it's considered contaminated. So there's a couple tricky aspects to it, but ultimately we would recommend that they recycle the third cycle, which is going to be your cleanest one because that'll be after they gets the initial wash, the pre-rinse, and then the second wash. So it's going to be at your cleanest water quality in your third cycle. And then the second and third cycle being recycled, there's a few other research opportunities that can happen for that to be implemented. So overall, we had about half a metric ton of CO2 reduced, as well as 76,000 gallons of water. And that's going to save them about $1,500 annually. For the boiler replacement, I had one facility that they had a large gas boiler installed that was mainly to heat up water tanks, which they have already implemented and replaced with electric heaters. So they asked me to understand the savings that they are seeing and could still potentially see from replacing this boiler. So how I started out with this is we got some of the gas bills, took a look at what they were before they replaced the boiler versus after, and kind of averaged those out for the month to kind of understand what reduction they've seen in gas. We also took a look at the electric heater specs, what wattage they run on, and also the hot water tank temperature and size. I learned a very fun conversion that Chris actually helped me find. So we were having trouble connecting these things all together, and finally Chris came up to me and said, okay, I remember 1 BTU is what it takes to heat 1 gallon of water 1 degree Fahrenheit. So that kind of connected all the dots, and once we understood how the hot water tank, what temperature and size that hot water tank was, we were able to get that down to BTUs and go from there. So this, like I said, is already implemented. They're already seeing savings, but over the next year, this is about the average they can see annually, and it's going to be around 639 metric tons of CO2 reduced, almost 12,000 MCF of gas. That's a lot, and around $150,000 in savings. So massive, massive project. Moving on, solvent recycling. This was also requested at 3 facilities. Most of these facilities use MEK for cleaning and painting as well. So what we ended up doing was we asked the company, how much MEK do you buy? How much do you dispose? What are the prices that you pay for all of this? And then we ended up using the EPA hazardous substances Excel sheet to pull like a 92% recovery rate of this recycler. So this recycler, if you take a look at what you are currently disposing of in hazardous waste, and then multiply that by the 92% recovery rate of this recycler, you're going to cut back your disposal costs by quite a bit. So you're going to end up being able to recover a lot of solvent, and it's going to be reused through this recycler. So ultimately, out of these 3 facilities, I ended up recommending this combo 655 unit RAM. This was actually previously recommended to another company by one of our PPI staff here about a year ago. And so it's a very nice machine, and that's what I use for all of my calculations. So overall, we're going to get over 4,500 gallons of MEK reduced, about 30,000 pounds of VOCs reduced as well, and going to save about $35,000. And this is not including savings on disposal costs. So this is just the initial purchasing costs that we're going to see saved. Okay, last big task was electric forklifts. I know there's 1 or 2 other interns that are also working on electric forklift projects. There is one facility that they are already starting to implement this. It's in progress. Ultimately, they were a completely propane and diesel fleet before they decided about 2 years ago to start changing to electric. So they asked me to estimate the savings that they're going to see from these once they're completely transferred over. So what I ended up doing was we looked at the capacity of the battery inside the machine, the electric forklifts, and converted that to annual kilowatt hours that they're going to be using. We looked at the propane usage. We got sent bills of just propane bills. And then we also looked at the cost of electricity. So this project is a little tricky. To find the total savings, we have to consider the savings from getting rid of the propane completely, and we have to subtract the electricity costs of these new electric forklifts from that savings. And so when I do that, that actually brings a very interesting discussion of we're actually seeing negative numbers, which is not what I expected at all. Essentially, they are reporting, and from my calculations, that we're inputting around 66 metric tons of CO2 back into the atmosphere, and we're also going to be losing around $37,000. So this brings up the discussion of, is electric forklifts actually better than the propane? But there's a couple other things that we have to consider as well. They are reducing 18,000 gallons of propane, which is good. There's also less maintenance required for the electric, but rental costs, that's going to be higher. So there's a lot more research that needs to be done on these electric forklifts. My best guess is that maybe one of my assumptions could be wrong, and that's turning everything negative. But there's definitely some more progress needing to be made in this report. So to sum up my overall findings, this is a giant list of projects. All of these are recommended. 2 of them are kind of already implemented and in progress. Overall, we're going to see about 2,400 metric tons of CO2 equivalent reduced, and we're going to be saving around $340,000. So that's kind of my summary. I did not include the electric forklifts in this final total as it is in progress. It needs more research. So thank you. Do you guys have any questions? Thank you.
The boiler that was already replaced, what was the reasoning that they replaced it? If you were the one to do the actual analysis on the return on investment, I'm kind of curious as to what prompted them to replace it in the first place.
So this was explained very clearly to me when we met with our point of contact on why they replaced it. He showed me a couple bills from, because the gas prices fluctuate so often depending on everything. And so he pulled a couple months of bills where they were paying like double, triple what they are paying now without the boiler connected. So he was just tired of relying on what the fuel cost was going to be that month. And so that was their main objective as to why they changed it.
Makes sense.
What were they heating with those heaters?
Water, just water tanks.
Water tanks?
Yes, so they were about 628 gallons, and there was 2 separate tanks. One was to be heated to about 110 degrees Fahrenheit, while the other was to 106 degrees Fahrenheit. So they're turned off at night, and they need to be reheated up.
It was a zinc plating line?
Yes, so this,
Zinc
yeah,
plating
that's a better example. Yes, it's for a zinc plating line. That's what their primary purpose is.
So aside from the forklifts and the boilers, were there any other systems that were operating on some kind of non-electric fuel that you considered converting to electric systems? And maybe any that you ended up not recommending?
Converting to electric?
Yeah.
Or any other systems?
Yeah.
No, there were not, actually, not many. Would I consider converting from gas to electric? Definitely after finding the savings from the gas to electric forklifts, that kind of turned me off on, oh, wow, that's kind of a shocker. I wonder if it's that case for other equipment. I don't know. But then if you compare the gas boiler to the electric, so there's definitely a lot of range in these scenarios.
Yeah, I think it's important to mention that in this case, the sizing was one of the biggest problems that they were facing, because they had this massive boiler, and they were operating initially 2 lines, and they shut down half of their basically operations, and they still had that massive boiler. So in this case, the owner did the research and figured out how much what size of an electric heater they would need for those tanks, and they replaced it, and it was an immediate payback.
I mean, immediately. I have bills from the month after they replaced it, and the cut is
Yeah.
insane.
And we got a good sample of about 1 year before, 1 year after, so we could compare throughout winter and summer, which is very
Yes.
important when we run our analysis, but it was quite interesting to see the difference of that one.
I guess maybe heating might be a good example of going from gas heating to, that might be a potential.
Yeah.
But then it'll probably be the facilities to turn on. Yes.
No questions? One thing I was just going to ask if you could just talk a little bit about because you mentioned the solar panel systems and you did a great job, doing all that research and figuring out all the details because it's like you said, it's very complicated. There's so many details that you need to consider. So about the batteries. So the battery, so did you see a benefit of using the batteries? Did you recommend any of for any of those companies to implement the battery system?
Yeah, so the batteries, as Chris is talking about, is essentially going to store any energy from the solar systems that you're not using. And looking at a couple other projects that were implemented by Kansas Energy Program here, one of the PPI outlets, it's going to double our implementation costs pretty quickly. So it's hard to estimate, is it really worth it? But I did actually end up recommending a couple batteries to a few facilities. One of them is if they decide to not follow the net metering limit and go over the 200 kilowatt system that they're going to install in solar panels, I would probably recommend a solar battery, as if they're a super large system, they're going to be generating so much solar energy that if they're only operational for 10 out of the 15 hours of light in the day, that's a bad estimate, but they're going to be wasting that energy in it because it will not be sent back to the grid as they don't have net metering. So if they could install a battery, it would make sense for them to they would have more savings that way than if they were to implement that large of a system and waste that energy that's being produced by solar panels. Yes.
Do you have any idea how that solar panel analysis would change if you were considering a facility that was operating 24/7?
I actually, one of the facilities that I have is actually operating more like 22/7, 23/7. So not quite 24-hour, but they run a very large operation, and I ended up not recommending any solar energy for them as their energy output, or yes, excuse me, their energy usage rate now in kilowatt hours is extreme, and no amount of solar panels is really going to cut them to be net zero, which was their main goal. And they also wanted to, this was the company that they wanted more reliable energy, which they told us the electrical grid in their area goes down quite often. And so that was why they were looking at it. And I actually found out a fun fact that solar is still connected to the grid. So when electricity goes out, solar panel is going to go out as well due to safety of the lineman workers. So unless you have a battery, which like I said, is going to double your costs, you're not going to have that reliable energy that he was looking for. So the 24/7 production, it can be beneficial, but it depends on the size.
Mhm.
Yes.
So,
It's just about solar panels.
Yeah,
too.
go ahead.
So I don't know if you even got in the weeds this far, but did you ever did you consider at all the amount of daylight that we have in summer versus winter and whether or
Yeah.
not that's
So that's where PV Watts comes in. PV Watts kind of takes care of all that for us, which was fantastic because I had a couple companies offer, hey, would you like to see, we have recording the thermal energy and sunlight. And I'm like, well, that's quite a lot of data to sift through per year. Months fluctuate. Some months we have hotter. I think that this summer's been quite a bit hotter than last. So that is included in PV Watts. They take an average solar radiance, thermal energy of that area, and they convert it into per month. So a good example is I've seen a range from 14,000 kilowatts all the way up to 33,000 kilowatts. And 33 is going to be your mass production during the summer months. So,
yeah,
we did account for that, yes.
so
Yeah.
mine is still again in solar panel. So I did, my plant was working for 24/7.
Yeah.
And the company that I looked for, I got a quote, they were calculating federal tax credit saving. So did you get that kind of quote also? It's they were saying they can get a 40% tax credit saving from the original implement. So that was a lot, but they said it's like, okay, we have done projects with that. Did you get, like, saw any kind of quotation like that too?
So are you saying like, grants and benefits or?
No,
what?
so the company was not like eligible for any grant because it's a bigger company.
Yes.
But then the quotations that I got from the supplier, they said they can get saving from the federal tax credit.
Yes, yeah, so the ITC, that's what I mentioned, the federal investment tax credit or installation
Okay.
tax credit, I forget what the I stands for, but yes. So that's gonna cut back about, I think it's 30% around that of the implementation costs, and so there's a couple rules you have to follow where you have to be accepted, and there's a couple little fine print things that I didn't delve too deep into, but ultimately, most of these companies that I worked with did qualify for the ITC. So that's gonna cut back 30% of their installation costs, which helps a lot in the payback period. So they were also considered, and I found out that the REAP and the ITC grants can be combined, so essentially you're gonna be coming back around 80% of your installation costs.
Yeah.
And so even with, and there's a couple scenarios, even with 80% cut, it's not gonna make sense. So, yes, there was a couple scenarios where the REAP either applied or they didn't apply, but the ITC throughout, yes.
Any other questions from the audience?
Sorry, there's so many rabbit holes. I know I feel a little scatterbrained even just talking about it. I've been with solar panel specialists multiple times and like all this is going way over my head. I'm just here to estimate the feasibility and tell the companies yes or no, so.
Yeah, because as a circuit rider, since this is the program that we keep companies confidential 100%. So in a lot of cases, it's really hard for us to get an actual quotation because the solar company needs to visit the location, check out exactly the route.
Access to the
Yeah,
buildings.
access to the building,
There's a
all
lot of
those
things to go.
details. So it gets, and I know that we had a couple of companies that did go into the weaves of the actual quote.
Yeah.
So our idea was to provide the company with at least an idea. Is this something that should pursue further? Hopefully with an intern next
Yeah.
next summer
That would be
to help with the implementation of the project. Yeah.
I don't remember you having a circuit rider last year. That.
Yeah, every year.
Every year?
Every
Okay.
year. Yeah. Yeah.
Yeah, I had some pretty complex projects this year, but it was actually fun to do the lighting and compressed air audits because those were easy.
Yeah. There was one company that had, I think out of the 110, how many were, 92 were from one company
Yes,
only.
Alice?
Yep. Yeah.
that was for most of Los Angeles.